Hello ladies and gentlemen, this is Light and Color and correlates with chapter 17.1 in your textbook. Your key concepts for this video are: how do we use light interactions to classify materials? What determines color? How do colors combine? Let's first talk about those light interactions. Now, there are three things that can happen when light comes into contact with an object. Some of the incident light rays, meaning the incoming light rays, will be reflected or they'll bounce back. Some of the incoming light rays will be absorbed, and others will be passed through or transmitted. Now, depending on how much of the light rays reflect, absorb, and transmit depends on what we classify that material as. So, if no light passes through, they're all either absorbed or reflected, we call those objects opaque. If some of the light passes through, and some is absorbed and some is reflected, that would be translucent. And if all of the light passes through, all of the light is transmitted, we call those transparent. Now, what determines color? Opaque objects, remember these are the ones that no light can get through, so everything's either reflected or absorbed. Opaque objects are whatever color is reflected to our eye. So here in this black surface, we have white light, which you know is the presence of all colors, hitting this surface, and all of the colors are absorbed, so we see that color as black. Versus when you see something as white, all those colors are coming to the surface and they all get reflected back, meaning we see it as white. Or, like plant leaves, we see most of these as green. That white sunlight is hitting those leaves, and all of the colors, except for green, are absorbed. The rest are reflected. And this is actually why, if you ever look at plant lights, they have ranges of blue, green, and red. The green gets reflected back, but the blue and the red are what the chlorophyll used to create photosynthesis. Depending on what light you're using depends on how you see it. So if I shine a red light on this red apple, I'll see the apple is red, but the leaves kind of look black because there's no green light to reflect off of them. I shine a green light on the apple. The green leaves still look green because that green light bounces back, but there's no red light for the red of the apple to reflect back, so it just looks black. If I were to shine a blue light on this red apple, everything looks black because there's no green or red to be reflected back, so all of the blue light is absorbed in. Now, if I've got a translucent or a transparent object, this behaves with color a little differently. The color is whatever is transmitted or passed through. So think about a stained glass window. As the light comes through this blue piece, that light looks blue because that's what's passing through. Or the green piece comes through. Down here we've got this light shining through this gel, so if you ever do stage lighting, you put gels in front of the lights to create different moods or ambiance. This is how, in movies, even if the filming goes into the middle of the night, they can create a scene that looks like it's early morning or in the middle of the day because they're able to use those gels to replicate what the light would look like during the day. So let's talk about how colors combine. Think back to primary school and your basic art classes as well. You've got your primary colors. These are your three basic colors that combine to make any other color. You've also got secondary colors. These are two primary colors combined in equal amounts to create another color. So you'll have three primary colors and three secondary colors. And you might think, oh yeah, I already know this. I'm betting you might learn some new things here. Now, when we're talking about color, the first thing we've got to talk about, are we talking about pigment or light? If we're talking about pigment, we've got different primary and secondary colors. Pigments, like paints, their primary colors are yellow, magenta, not red, and cyan. So we've got yellow, magenta, and cyan. Their secondary colors are red, green, and blue. So in paints, the secondary colors are red, green, and blue. If we were to take all three primary colors together and mix them, we would get black. So those are how colors combine in pigments. So instead, let's talk about light. Light, the primary colors, are red, green, blue. The secondary colors of light are yellow, magenta, and cyan. These are switched or opposite of the pigments. Because remember, pigments, their primaries are yellow, magenta, cyan. But in light, that's the secondary. And just like we're doing the opposite of primary and secondary, if we combine all the colors of light, we get white light. Now, you might think, oh, that's weird, but just think about like your TV or your phone or when you're modifying a picture on some kind of program. The colors that you're able to change are red, green, and blue. Or when you're plugging in the colors into your TV, you get red, green, and blue, because those are what combine to create all the different colors when we're talking about light, so like in monitors and computers. That's it. Be sure your notes hit all the key concepts and vocabulary, and feel free to try this challenge question.